Good morning, boys and girls. You're at home right now, but you have to watch this video and then do the activity yourself. You're going to open the Perfect Square project in the folder called 04 Activity 4.9 Error folder provided. So you'll find that in your data files over here, Chapter 4 Data Files, Activity 4.9 Error. Okay, and it looks like that. Now we're going to calculate whether a number is a perfect square or not, and we're going to use a decimal, a random number. Now the code in this program already exists. See all of that? Yeah, we've got to go and fix the code. That's one of the most difficult things to do, is fix code that already exists. So the program should do the following: get a random number between 1 and 500. So I'm assuming they mean from 1 to 500, so forget about that word between. From 1 to 500. Determine the square root of this number, and we're going to get the square root of the number. Then you're going to get the value of the square root if the decimal is removed, and get the value of the square root if the square root is rounded. And then compare the two. And here's a note here. We know that if you have a number, let's say we have a number 26. Okay, 26. Now we know that it's not a perfect square. We know that 25 is a perfect square, not so, because 5 times 5, you can get the square root of that number. It won't have decimals. It'll be the number 5. But the square root of 26 is different. I think we have in Excel, we have a formula. Let's say we can insert we want to find the square root of a number. You'll find a square root function. There it is. Square root equals square root, and we can just go and put any number. Let's say we're going to use that number 26. It's actually not 5, but if we had to go and get the decimal points of that number, you'll see that 5 is, let's go and make sure we can see the decimal points. Okay, we can. Just, there we go. It's 5.1. So therefore, that is not a perfect square. So if the square root and the trunk value and the round value are all the same, and if the square of the trunk value is equal to the square of a round value, then the user must press yes, otherwise the user must press no. Well, that sounds a little bit confusing, doesn't it? But we'll get into it just now. Just remember that perfect square means that there are no decimal points in the square root. How do we determine if a number has a decimal point? If I trunk that 5.10, trunk, oh wait, no, not there, sorry. If I say, if I want to trunk 5.10, what will I get? I'll get 5, not so. If I round 5.10, what will I get? Well, I'll get 5 as well. But let's say if the square root, the trunk value and round are all the same, fine, they're all the same. But if the square of the trunk value is equal to the square of the round value, then we must press yes. Yeah, so that is a little bit tricky, because this 26 is 5.1. The square root, oh wait, square root of 26, sorry, not 20, 26. Square root of 26. So this is the square root of 26. Okay, that's 5.1. Let's go and get some more decimals in here. Okay, it's actually 5.0999. If I get rid of all those decimal points, I'll get trunk. If I round that, I'll also get 5. So that actually is not going to be a very good algorithm, is it? We want to see if they're equal. So the algorithm is get a random number between 1 and 500. This is the algorithm, okay? These points here. call it an algorithm. Basically, how are we going to solve the problem? Determine the square root of the number. Determine the value of the square root if the decimal is removed. The decimal is removed. Determine the value of the square root if the square root is rounded. So we're going to round the square root and we're going to remove the decimal. Fine. Square the value of the square root after the decimal has been removed. So I'm going to square that 5 and square the value of the square root after the square root value has been rounded off. Well, that means 26 is a perfect square, which we know it is not. Never mind. We are going to continue with our issue. Let's say square the value of the square root after the decimal has been removed. Fine. I mean, if I do it this way, I've removed the decimal, so that's 25. I've rounded and I still get 25. So, okay, if I'm just going to go and put in, let's say that number. Let me put in a different number, 324, and that's 18. So that's a perfect square. 368. That is 19.1. So 398. 19.9. So if you see here 398, if that number was chosen, then 19.94999347. If you trunk it, you'll get 19. If you round it, you'll get 20. If I square that, 19 times 19, and if I square that, I'll get two different answers. So therefore that is not a perfect square. So that's what they were getting at here. So that 26 is a little bit of a bother, but they're saying, okay, that's the rules for a perfect square, so 26 will be a perfect square then. That's what they say, as far as this goes. As far as this algorithm goes, fine. Right, first of all, we're going to look at other things first. We've got to go and find errors in our program. So what's the first thing? And then test your corrected program by running it and check whether values are correct according to what the description of the program should do. If there are still errors, then use any method. So there are some errors. There's syntax errors and probably runtimes errors. So if you open the program and you run it, you'll see there's an error here. And we're going to see why. This is called a runtime error, not a syntax error. There's no spelling incorrect here. What we are doing here is we're saying square root of I trunk, we're making it equal to an integer. And square root cannot be an integer. Okay? The square root and this one over here, square, we cannot make an integer equal to it. So that's got to be r square. Alright, but if you run the program, is r square declared anywhere? No, we've got to make it declared it. R square, we've got to declare it. And we get rid of I square. So we got rid of I square. So I'm going to run the program again. Yes, there will be another more, because why? R square is supposed to be here. R square is supposed to be here, and it's got to be float to string. Right, run the program again. Right. Now, of course, there's no more runtime errors. So, if I click on calculate, it's not giving us the right answer at all. We've got the number 3. 3 is the number. What is the square root? It's that. You trunk it and then you round it. Trunk you get 2, round you get 2. The square of the trunk is that, and the square of the round sort of doesn't look right. Hey. So let's go and see what's going on here. First of all, okay, here's the first one. They're getting a random number of 1 to 5, but we want a random number from 1 to 500. So 1, 500. So that was the first logical error. Okay, then determine the square. That was our first logical error. Then we're going to determine the square root of this number. Okay, they've basically gone and put I number. Why did they round it? Because I number is already an integer. You don't need to round a number that's already an integer. So get rid of that round there. So that's logical error number 1, 2. That was the first logical. There's another logical error. They get the square root of our number. Okay, so they did that right. Determine the square root of this number. We're doing the second bullet there. Determine the square root of the number. We look at the code. R root equals square root I number. Good. R root is a real number. And that's fine. Then they say, okay, we're displaying the square root of the number. Okay, they're displaying it there. Okay, that's good. LBL root.caption, which is this one here, in that label. So they're displaying it there. Then get trunk. I trunk. I trunk is not round R root. I trunk is trunk R root. Okay, so we get trunk of the root. So it says determine the value square as decimals removed. That's trunking. Okay, we got that. And then we're displaying it into LBL trunk. Displaying it there. So we get our square root, trunk it, and display it in the label for trunk. Then we're going to round the square root. That's fine, that's good. And then we display that rounded number into the label called LBL round, this one over here. That's done so far. Then what are we doing now? Square the value of the square root after the decimal has been removed. Square it. Why am I getting the square root? Square trunk, so it's got to be square trunk, SQR trunk, and float, and then we display the square in the LBL square. So we're squaring the trunk, we put it over there in LBL square. That's right. And squaring our round, well, it shouldn't be a square. I told you it's supposed to have a real number, so R squared 2. So that is a, it didn't give a runtime error, but logically we're supposed to, if you're using a square function, a real number must be the data type. It just so happens that luckily R round is an integer, but R square is what has to be used. So that must go away. R squared 2, not I squared 2, R squared 2. So R squared 2 is squaring the number after the square root that we've rounded. So we've rounded, we've got R round and R square. Oops. I round and I trunk. So we squared R trunk, we square R round, and display R round into the label called LBL square 2. After we squared, so we're taking the trunk and the round and we're squaring it. Okay, so what that is, we take the trunk and the round and we square. What's 19 times 19? I know 20 times 20 is 400, but what's equal 19 times 19? So that'll be 361. So if they're not equal to each other, then it's not a perfect square, like this 398 is not. So we get the trunk of, that's the square root. We trunk it, we round it, and then we square it to get those two numbers. Let's go back again. This is the square root. This is the random number, and this is trunk of the square root. It's round of the square root, and that is squaring it. Squaring these two numbers will give us those two numbers. Okay, squaring those two gives those. If they're not equal, then that number there is not a perfect square. Now that is the algorithm that they want us to use. I don't fully agree with it, but we'll use it because that's what they said. Right. Test your grid by running and checking whether the values are correct according to description of what the program should do. If there are still errors, use any method you learn to fix and find and fix errors. Well, that's what we are doing. We're busy fixing the errors. So I'm going to run the program. I've done that. I think I've fixed the errors, and I'm going to put a number in. There's still errors. I forgot about a comma there. Okay. So, oops, still errors. Oh, okay. Comma's not supposed to be there. Good. Still errors. Okay. Can't find what random range is. Well, we've got to put math right at the top here. Comma and math. And then we can use random range. Always remember that. You need the math unit in the user section in order to use random range. Just the way it is. Right, just going to put some random numbers in. I'm not happy with this 26. But of course it's going to be a random number, so we can't tell what the number will be. And if we click, see now, if the square, the trunk, and the square round, they're not equal to each other, so we click the button no, and then it goes red. You know, there we go. So we click again. Click yes, and then we go back to green. Now, I can't see any of that on my screen, so that is how it is, people. I mean, they've changed. If it's no, we make the form color CL red, and if it's yes, we make the form color CL green. I prefer a lighter color so I could see what is behind all that color. Might just be my monitor, but I'm going to go onto my color palette over here and check what we've got. Can you see we've got other colors that we could use which are slightly lighter. CL money green is light and CL fuchsia is pink. That would be a form of red, wouldn't it? So CL money green and CL fuchsia. I'm going to use those. CL money green, maybe I'll be able to read. And CL fuchsia. Let's see if that helps. Oops. Oh, doesn't like my word, CL fuchsia. I guess I must have spelled wrong. Go back to this. F-U-C-H-S-R-A. F-U-C-H-S-R-A. Well, that's how you spell it, apparently. Right. Take note, I can actually make this larger because we can't actually see the numbers there. Calculate. Right. Is it a yes it is? And 36, no it isn't. So it's slightly better to see through. Anyway, you learned a couple of extra things today. And if you finish this, then you must make sure you have finished your theory quizzes as well. And we'll see you at school tomorrow.